Okay. So, I'll kick off now as we're getting on towards a few minutes past the hour. People can join as they will. My name is Eddie Thompson. I am a solution engineer here at Sumo Logic. And today I am going to be talking about Kubernetes and Sumo Logic and how our Kubernetes solution can sort of help you with solving the Kubernetes challenge, as we say. So, a couple of housekeeping items. This session is being recorded. We will be providing the link to that later. Additionally, if you have any questions, you can click on the Q&A button and ask the question. I'm being ably assisted today by our APAC manager for sales engineering, Ryan Johnson, and he will be answering any questions that you have live in the text panel. If there's anything that I think will be worthy of digging into a bit further in the demo, I'll throw to that as well. But basically, I'm going to go through a few slides, bit of an introduction to what Kubernetes is about, and then most of it's going to be a live demo of our solution. So thank you very much for joining, and I shall dive into the material. I'll pop my video off now because it's going to be a lot of me reading and talking. Thanks. Yes, Imran, I will be giving a brief intro to Sumo Logic as well. Thank you for that. So, Sumo Logic, who we are and what we do. We are the industry's first and only continuous intelligence platform. And what does that mean? We take in your logs, we take in your metrics, we take in your security events, and we allow you to provide some different lenses to this data, be that operational, security, business, or even global intelligence. That's when we actually allow you to benchmark yourself against other people in similar industry verticals to you, seeing how your configuration matches up, how the threats you're seeing match up. We've got over 2,000 customers worldwide, and we are analysing data in the petabyte scale every single day. So I'm going to move on a little bit into a bit of 101 about Kubernetes. So for those of you who've been using it for a while, this is going to be stuff you know. It's foundational information, but it's a worthwhile refresher, and it helps us to provide a bit more grounding into why what we're providing here is a bit different and where the value lies. So, intro to Kubernetes, or K8S, as you will commonly see it rendered. Why K8S? Because there are 8 letters between the K and the S. That's going back to the IRC and BBS days for those who remember them. But Kubernetes, what is it? It is an open source container orchestration platform. It was developed by Google. There it was known as the Borg project, and now it is managed by the Cloud Native Computing Foundation. A little bit more on those in a while. It provides automated deployment, scaling, and operations of application clusters of applications across clusters of hosts. Now, it provides desired state management. That means that its configuration is declarative. We tell Kubernetes what we want, not how we want it to do it. So you tell Kubernetes that you would like something to exist, you would like it to have N number of replicas and be available to the world on a certain port. And it does the rest of that under the covers. You don't really need to worry about that. You just tell it, how you would like it to be at the end state. So that's what we talk about. That's what we mean when we talk about desired state management, that declarative configuration. So everything in Kubernetes is by design ephemeral. So Kubernetes achieves its elastic ability to scale and contract by taking over how pods and the containers within those pods are deployed. So it knows the resources it has, it knows the limits it's set, it knows the configuration that you desire, and it works on making sure all that happens under the covers. The key to this scalability is that ephemeral pods maybe have a lifespan of hours, minutes, seconds even. So things need to be architected in such a way that you're not needing to update the configuration of something that may only have a lifespan of a few moments. And the other thing that's important about Kubernetes is it runs anywhere. Private, public cloud, bare metal, VMs, it doesn't really matter. You can have it up and running wherever you like. So the Cloud Native Computing Foundation is part of the Linux Foundation. It's a non-profit, and it's actually what governs the Kubernetes project now that it's been open sourced. And it also governs a lot of other projects that are related to our collection strategy as well, which I'll go into a little bit deeper. So it was founded December 2015, so we're only 5 years old now. Got members across all sorts of verticals, from the major cloud providers, network providers, hardware providers, software companies. It's pretty broad stuff. Sumo Logic is a silver member. We contribute code that we're writing back to these open source projects within our collection methodology. Now, a little bit about Kubernetes terminology. So the language that we use when we're talking about Kubernetes. Now, it's a little bit dry, but it's important to know, to be able to understand when people are discussing Kubernetes, they're going to use these terms. There's only a handful of them to get the basics that we need. So first of all, a cluster. So a cluster is a Kubernetes deployment as a whole. So that's the applications, the nodes, so that we've got multiple nodes within a Kubernetes deployment. We need at least two. So you need at least a master and a worker. In practice, you will likely have at least two and many more worker nodes. That's where the actual containers and pods are running. And the master node is what is doing the administration and controlling what actually goes on. You can have many master nodes or more than one master node for redundancy and high availability. The worker nodes, as I mentioned, are where the compute that's running. So that's your VMs, that's your capacity akin to VMware or an EC2 instance that is allowing the actual application software that's being run. So a node is a worker machine. So that may be a physical host, it may be a virtual machine, and it has the local daemons and services that are necessary to run the pods. It's managed by that cluster control plane. So daemons on a node include kubelet, kube proxy, and the container runtime, commonly Docker. Now, a pod is the smallest object that you can interact with in Kubernetes. It is the smallest thing that you can deploy. Now, pods contain one or more containers. You cannot deploy a container directly. You can only deploy a pod. So even though we have containers, within Kubernetes, we talk about pods. So pods may be moved around for load balancing purposes, be spun up, spun down. And pods are commonly managed by a deployment. Now, a container is what you actually produce from your CI/CD pipeline. It is the software, your application, the associated libraries, and anything else that you need to make that software run. And it is able to sort of abstract a lot of what we used to need to package up with virtual machines. And it's much more lightweight and allows us to run many more instances together. It's much more efficient. And it makes it a lot easier for us to scale these things between different cloud environments. So we can have a container that we've built and we can run it on our private cloud. We can run it on AWS. We can run it on Azure. We can run it on GKE. It's much easier to scale these ephemeral pods than traditional infrastructure as well. So deployment. Now, the deployment is the common way that we will have pods deployed to our Kubernetes cluster. So the important thing about a deployment is that it manages all the associations and settings for the pods that we have deployed. We can deploy multiple types of pods that are related within a deployment and specify the desired state management for that particular set of pods and what they're exposing. Now, the important thing about that is that when we need to make a change, we make a change to the deployment and Kubernetes updates everything else for us. So if we want to make a change that affects 6 pods, we make the change to the deployment and everything else is done by the scheduler. We don't need to go and manually update 6 pods, which would be very inefficient. Namespace. Namespace is, well, it says here, an abstraction to support multiple virtual clusters on the same physical cluster. Really, it's more like your organizational folders within a Kubernetes cluster. It's how you organize your applications, services, business units. And the important thing is that names need only be unique within a namespace, not across namespaces. So if you're running up a dev, a QA, and a pre-prod environment on Kubernetes, you can have the same names reused across 3 separate namespaces and exist all on the same physical infrastructure. Very handy. Service. Really important thing. The service is how we expose the applications running on a set of pods as a network service. This is what we are presenting to the world, to our customers. So if we're running a payment service, a user service, a map service, that is how those particular microservices are actually being exposed on port 443 on a particular URI. That's the key. You'll see later, this is a key differentiator for us, but when people who aren't running a Kubernetes deployment, when they're not sort of the DevOps engineer, they're a developer, they are working on a microservice. As far as Kubernetes go, they probably care about what their service is and possibly what namespace they live in, but that's what they know is they have a service that they're putting out to the world. They don't really care about what you're doing with Kubernetes so much. So our Kubernetes app, it's deployable from within our app catalog, and it provides visibility into the worker nodes and their application logs. You can monitor and troubleshoot container health, replication, load balancing, pod state, and hardware resource allocation. It also utilizes Falco to provide monitoring and detection of abnormal container application host and network activity on that security side as well. So that's enough of the slides. We'll do it live, jump over into a bit of a demonstration, and you can see how things are within our Kubernetes solution. So this is Sumo Logic. This is our Explore view. So this is something that we built, and it's came off the back of customers have been sending us Kubernetes data for quite a while now, and there was difficulties in traditional infrastructure sort of tooling about how we were dealing with this new world of ephemeral data and containers and the relationships between the abstractions that were going on. It was difficult to keep track of what was what, and it didn't really follow the mental model that people had for Kubernetes. And so the Explore view was something that we launched last year at our user conference, Illuminate, and we've just sort of moved into the 1.0 release of our collection strategy as well, which I'll drill into a bit later. But this is sort of like the key thing about our Explore view is it actually, I'm in the deployment view at the moment, but it gives us the ability to view the data from some different lenses. So the deployment view, the node view, the namespace view, and the service view. So I'll jump over to the node view. And I can see here I've got a cluster, proto1 troubleshooting.info. So this is some website data that I've got coming in. So it's live data that's running in. This isn't, and basically within each of these views, it allows me to visualize the data in a certain way. So from here, this is the cluster overview dashboard. I have the ability to drop down here and see other dashboards which are contextual to the data that I'm working with. And this point here, I can see cluster stats, and it gives me an overview of some high-level metrics that are useful to know. So things like my CPU utilization, memory utilization, my disk space, any drop network traffic, how many CPUs, how many total memory, errors that I've got going on, security rules, and I can see here pods that are running in a nice honeycomb view as well. Now, I can see here I've got a couple of pods in a failure state, and as an example, this is sort of how things work in the traditional infrastructure sense. I open my cluster and I can see my compute nodes. Pretty normal. I can expand one of these and it drops me actually into the node dashboard. So the dashboard has changed contextually, and you can see here that it's building out the filter as I click through, and it's giving me some much more technical deep dive metrics on what's actually happening for this specific node. But if I wanted to actually find what was going on with a specific pod, as you can see, aside from being in alphabetical order, these things are pretty broadly distributed because Kubernetes is basing where these pods are situated based on load and availability profiles and other things like that. So it's not a great way to be able to find what you're looking for. Really good if you're actually troubleshooting a specific hardware or load issue. But if we want to see what's going on with the pod, a little bit complicated. What tends to be much more easy to use, we can jump over to, say, the namespace view. So this has sort of got some common things, cluster overview. It's a common dashboard across how we drill down. But now, say I've going back down to my honeycomb here, I can see this particular pod here. They've got a nice green state and it's consistent, but these ones, they're going up and down. So there's some issues with these particular containers. I can see it's related to PagerDuty and Carbon Black. But now if I drop this particular one down here, I can see that it's logically ordered by namespace and what's going to be within them. I can drop them down further. and it takes me to a specific overview dashboard, and I can see the pods which are running within the namespace. Now, I can go back to where I was, and that's just an example to show the ordering, but more commonly, I would probably say, okay, I can see there is an issue with this particular one. I'm just going to click on it, and it gives me some options. So I could do something like drill down to the logs, or possibly do a log reduce to get to the error signatures. But in this case, I'm saying, okay, I want to see what's going on at the namespace level. I could go to the pod itself. And it's a good example here to see that beyond the pod name, we've got a couple of random strings, and that's due to the nature of these pods being ephemeral. Each time one is spun up, this is a newly generated string. And that's where the sort of traditional infrastructure model of something being onboarded and then eventually decommissioned and you know the name of everything starts to fall down a bit. So I can go, show me this dashboard, prod loggen, what is related. So once again, it's given me a new dashboard. This is contextual to where I am. It's showing me what's available, how many pods I've got running, how many pods I've got in a failure state, which pods have errors, which containers have errors, and their percentages, and the pods running within this deployment. So by deployment, I should say. Now I can see here the two, once again, in a failure state. Now, what's interesting to me is within these errors by pods, I can't see carbon black. I can see PagerDuty, so that one's in a failure state as well, but I can see that there's errors going on with that one. This carbon black one doesn't have any errors, so I'm going to drill into this one. So once again, I can click on it. It gives me the options. I'm going to say, let's go a bit more into the weeds, get down to the pod level. So once again, our dashboard has changed, it's contextual, and we're building out the filter along the top here. So we know exactly what we are looking at. And the first thing I can see here is pods in, well, that says crash loop back off if it has sufficient space, but one pod, and we can see pod restarts. And in the last 15 minutes is the time range I've currently got selected for this dashboard. So 23,000 restarts in the last 15 minutes. It's not in a good way. So it doesn't seem to be eclipsing any memory limits or CPU limits at the moment, but I can see these pod events, and these are coming in from the Kube API server that they're querying via the API, and it's saying back off, restarting failed container, and there's obviously quite a few of those. Now this thing here, this is really, really powerful. So this is actually tracking the metrics that we're scraping from Prometheus for the entire Kubernetes cluster. And we're presenting this in a timeline. So we can actually see a timeline of the pod state. So we can see here that the container, the metric is kube pod container status waiting reason. It's a bit of a mouthful. Apologize for the truck that's just driven by. And the reason is crash loop back off. And so then we can see proceeding along, the container has started and the metric is kube pod container status ready. And then immediately after that on the timeline, we can see that it has been terminated. So kube pod container status terminated. And the reason is OOM killed. Now, what is OOM? OOM is out of memory. So it looks like it's been killed off by the scheduler for an out of memory, but we don't seem to be eclipsing any memory issues here. So let's scroll down a little bit further and have a look. So here we've got our resource utilization for this particular pod. And aha, here we go. So within Kubernetes, when a pod starts up, you can configure limits and requests and limits. So a request is the amount of memory or CPU allocation that you make when you start up. And the limit is a cap that you can set. So just to provide some guardrails for your cluster to make sure that you're not worrying about noisy neighbors or a particular pod taking much too much memory if there's a memory leak or if someone managed to install a crypto miner on your cluster. But basically, this particular limit here is something that you can set. And this one here is the container memory working set bytes, so the amount of memory that it's actually used. So this is its initial request. This is the limit. And this is how much it's using. So we can see here that it's actually eclipsing that limit, and that is why it is getting killed off by the scheduler. Now, that is something that I can now resolve. I know that I need to raise the limit for this particular container, and that's something that I can fix relatively easily. But the important thing to note is all of this information that I've just gone through is provided by the metrics. So beyond this particular pod event here that's telling me that it's backing off and failing, there was no log message for the pod to tell me that there was a problem going on because the pod itself didn't have an error. It was being killed off by the scheduler. So if I was not monitoring the metrics for my cluster, I'd be flying blind in this instance. I would have a really hard time in determining exactly why this was happening. I'd be there on the command line, banging away commands and hoping that I came across something that was indicating to me exactly why this was happening. So that's a metric sort of use case as to how we can help solve problems within Kubernetes. So what I'll do is I'll jump back up to my namespace here and we'll talk a little bit more about some of the other views. So I'll go over to the service view for a moment. And remember I said earlier that we had the service view, the service within Kubernetes is how you expose something to the world. So that's what's actually you're putting out there. It's part of what is connected to your customer reality. So that tends to be when you have, if you're running the Kubernetes service for your company, when people come to you, they have a service-centric view of the world. They don't really care so much what's going on with everything across Kubernetes. They care what's going on with their service and the problem that they have. So if I have someone coming up to me and I say, okay, I've got a problem with my Fluent D service, I can then say, okay, well, which namespace was that in? And so we've got the Sumo Logic namespace. I can click into that one and I can actually select the service and it's going to give me contextually, again, my service overview dashboard. And I could say, okay, well, everything seems to be running fine here at the moment. I've got 6 pods related to your service and I can see them all here. And yeah, everything's running fine. So I don't know, you may want to check in with the network guys and see if there's anything happening on the load balancer or the CDN because yeah, everything's up and running as we expect here at the moment. Now, if I had to go and find all of these related pods via the infrastructure view, That's not easy. That's something that's actually quite difficult to do. So being able to find that data quickly within the service view and equally the deployment view, finding everything that is actually related to a particular deployment, where my pods are, how they are operating. So this particular deployment here has 2 separate pods, one in a failure state, one that's running. How many desired replicas, what errors, and incidentally, whenever you see no data to display within our Explore view, it's not always a bad thing. In this case, it's saying there's no errors. But yeah, that's a particularly powerful thing that's been done. And this is enabled by our metadata. So I'll jump back to the namespace for a moment. And as we mentioned, within our prod loggen namespace here before, we had two pods in a failure state. And we had a look into Carbon Black, and we know why that's an issue now. So let's have a look at PagerDuty. So this one's also going up and down. So let's see if we've got the same sort of issue that we had. So I can click here, Related Explore, drill into the pod itself. So I've opened up my pod dashboard, and this one is also in a pod restart crash back off loop. Back off failing restarted. So let's go down to the pod state here. Okay, this one's a little bit different. So start and crash loop back off. So what's this purple line? Okay, this is different. So we've got pod container status terminated, and the reason in this case is error. Okay, so we'll go down here, and yep, we're not eclipsing these CPU or memory limits like we were in the other. So there's definitely something a bit different going on here. Interesting. So what I might do is let's pivot across and actually investigate the logs. So I can click on this particular pod here, and I'm going to go under related logs, just click on all logs. And so we can see here that it's given me, it's taken me over to the Sumo log console. If you've used Sumo before, this is probably very, very familiar to you, but we've automatically filled in all of the related metadata. Now, interestingly enough, you won't see source category in here because we've got some more specific metadata that's being labeled for all of our Kubernetes options here. So namespace is prod loggen, the cluster, prod01, troubleshooting.info. The deployment that is related is PagerDuty, and the specific pod in this instance, and that's the string that's related to it. So I'm just going to have a quick scroll through the logs here and see if anything jumps out to me. Aha, okay. It looks like we have a 401 HTTP code. So that says to me that there is likely some issues with authentication. Okay, what have we got? Invalid cookies, blah, blah, blah. Access ID. That's interesting. So what I might do is I'm just going to grab this access ID, might put the time range out to the last 3 hours, and I'm just going to search across all my data for this particular access ID. Okay, I've got a few pages of logs. I don't really want to read through all of this, so let's hit the log reduce button. So this is our pattern matching algorithm. It's going to iterate through all the data. It doesn't sample. It's going to break them down into some signatures for me based on their structure and value. Okay, it looks like someone has actually deleted this access key, and that would probably explain that, that authentication error that I'm seeing. So we can actually drill into this. So I can click in and it's going to give me the details for this particular signature. Okay, well, let's have a look at the surrounding messages for this particular incident. Okay, so I can see that the user Kenneth has logged out. I can see that the user Shady plus Sock has logged in. And I can see that the user Shady plus Sock has deleted the user Kenneth and has disabled and deleted this particular access key. So it looks like a user has been offboarded by the SOC, but their particular access key here was still in use. And that's why we're getting these 401 failures for PagerDuty to authenticate, as this particular access key was still in use. So obviously got a little bit of a problem in our offboarding procedure there. We need to have the SOC to actually validate whether or not that access key is still in use. But more specifically, you can see there that from the same Explore overview, I've been able to investigate a problem by going first deep into the metrics to validate an issue that had no log message. And secondly, I've been able to drill into my logs directly related to a single pod and found an issue that was actually something which was a human error business process issue, but was showing up as a problem within my Kubernetes structure. And that's something that's pretty powerful, to be able to have the metrics and the logs and the security events, everything available in there together. Now, I just mentioned security events, so that's something I want to touch on briefly. So when I get back up to my Kubernetes cluster here, we can see here, top 10 security rules triggered. So what's that actually coming in from? So we can go to security overview. So this is data that is being provided by Falco. So Falco is a kernel level anomaly detection tool. So this is actually running deep within the kernel to actually see what is going on and trigger security alerts within Kubernetes. So a lot of people have been deploying Kubernetes, and it provides a lot of power, a lot of capability, but it is also providing an extra layer of abstraction. And if you are not careful, you can be introducing some security blind spots. Falco provides us with a way to expose this security information within our Kubernetes Explore platform. Now, if you're using some other vendors' security products for Kubernetes, that's perfectly fine. We've got several security partners who provide applications like TwistRocks, StackRocks, JFrog, X-Ray within our platform. But if you are not using anything at all, Falco provides you a level of security visibility which is far greater than flying blind. So we can see here the rules by priority, what our top rules triggered are, and these are all things that you're able to alert on as well. So, just want to drill into data collection and enrichment a little bit. And so I've given you an overview of how everything works within our Kubernetes Explorer. And now I'm just going to elaborate a little about how we got that data in there, and also about how I was able to pivot between those different views. So, collecting data from Kubernetes. In this instance, we are collecting logs, events. Now, events are those which are being queried from the Kubernetes APIs, metrics, and security events. So for logs, we are using FluentBit. Now, everything we've got here within our collection strategy is an open source project governed by the Cloud Native Computing Foundation. So we're working completely within this Cloud Native Computing Foundation box. These are the tools which the industry has coalesced around for Kubernetes. We're not reinventing the wheel. We're trying to extend the wheel, make a better mousetrap, whatever you want, analogy you wish to use. But FluentBit came out of the FluentD project. It is a lightweight version written in C, not as many plugins as features as Fluent, but uses not much memory and is used as a lightweight log router. That's deployed as a daemon set, so every single node within your Kubernetes cluster has a FluentBit pod, which is grabbing those logs as they are written and sending it down to our enrichment pipeline. Now, FluentD, we've written a Sumo Logic Kubernetes plugin for FluentD, which actually queries the Kubernetes API server for that data. So that's where we're actually getting those Kubernetes events via FluentD, and that is being forwarded on down the enrichment pipeline. Prometheus. We are using a Prometheus operator for Kubernetes. Now, Prometheus came out of SoundCloud and was open source there as a metrics platform they built. Hugely powerful, very popular, and provides fantastic auto discovery and auto instrumentation capabilities that we're using for Kubernetes. The issue with Prometheus traditionally has been scaling. So scaling, ending up with silos of Prometheus within an organization. We are trying to grab what Prometheus is best at and take away those scalability issues by actually forwarding on those metrics from Prometheus to our scalable metrics backend in Sumo. So that goes on the enrichment pipeline as well. And as I just elaborated on Falco, Falco is there for security events, picking up either from the kernel itself or possibly via something like eBPF if you're using GKE. All of this is being deployed by a Helm chart. So it's actually a one-liner to deploy the entire Sumo Logic Kubernetes solution after you've filled in a few values to a YAML file. But this is the secret sauce, our enrichment pipeline. So we have a FluentD deployment, which is receiving all of these logs, events, metrics, and security events, and tagging every single one with the service, the deployment, the namespace, in addition to the more traditional infrastructure-based node pod container. This is what allows us to pivot between these different views for the data set. This is what allows us to know that a particular pod is related to a particular service or a particular namespace, and give you that visibility within that common and logical viewpoint within our Explore view. This is what makes the magic happen. So a little bit dry, but really important to understand that's how we're able to drive that value. So I talked about this earlier, and this idea of discoverability and infrastructure versus the service view. So as I showed you, when we had the the infrastructure-based view, the node view within the Explore, everything was sort of scattered around because that's how things are being done for availability, for managing our capacity to the best of its ability. We want to pack as much stuff onto the infrastructure so we're not wasting money on compute. The problem is when we're troubleshooting, it's complex, it's slow to find issues, and more importantly, it's disconnected from the customer reality. The service view, that service-centric viewpoint, everything was logically ordered. If I clicked on payment, then I could see the payments, pods that were related, the same for the user, the same for the service. It's simple to understand, it's quick to find, and it's tightly connected to the customer reality, what you are actually putting out to the world. And that is a hugely powerful benefit. So we've actually sort of trying to unify the Kubernetes DevOps and SecOps sort of ecosystem here. And we're able to sort of partner with a lot of different providers and get that data into one place and actually provide you with a common view. So CI/CD providers like CircleCI, CodeFresh, Harness, they're all able to send their data into us as well. You might be doing on the DevOps side where you're actually running your Kubernetes platform. So you might be running it on, might be running it yourself, but more commonly these days people are running things on Amazon, on EKS, or possibly Google GKE. On the SecOps side, as I mentioned, we've got Falco. That's bundled in with our solution. You don't have to use that, but yes, you've also got players like Twistlock, StackRox, Aqua, JFrog X-Ray. They're all providing container security, visibility, vulnerability monitoring, things like that. And that is all visible within our one platform. So as an example, I know I've got Twistlock installed here as well. So within this particular view, I can click on my cluster and see all of my Twistlock data within the same view. I can see what my vulnerability scans for my particular containers have been looking like. That's all available there as well. If I can sort of show you a little bit more from our app catalog. So I can go to Kubernetes, and these are all the related applications. So K-Audit, Aqua, Istio. So if you're using Istio for your service mesh, we've got apps to actually give you visibility there as well. StackRox, and as mentioned here, Twistlock. So these little ticks here, that let us know that this is actually a partner developed application as well. So they've actually built it for Sumo as a partner with us, and all of those are actually visible within that Explore framework. So last of all, as we're getting towards the end here, try it out. So please, if you haven't used Sumo before, you can go to sumologic.com/sign up, or just go to sumologic.com and click the button in the top right-hand corner and sign up for a free trial. And if you wish to have more information, yeah, sign up. Someone will reach out to you. You can have a chat to a solutions engineer about your particular situation, any problems that you wish to solve. And if you wish to continue the conversation, please join us at our public Slack channel, the Sumo Logic Dojo. So if you go to slack.sumologic.com, you can sign up there. Lots of the engineers are there. I'm in there, and people can ask questions and have a chat to other customers, tend to help each other out with things like queries and how-tos as well. So it's a really handy place to go. It's nice and live and dynamic. It's not just sort of like throwing a question onto Stack Overflow. But thank you very much for your time. I really appreciate it. Hope it's been informative or entertaining, at least one of the two. And as mentioned before, the recording will be available to all of the registrants. So thank you very much for your time. And yeah, that's all from me. Cheers.